operations manager for Chill production station. Just a quick introduction to the site here. Basically, the site's been commissioned now for 18 months and presently loading a tanker here. It takes our oil to market through to a male tank farm, and basically only other product shipped off site is water, and gas is exported through to Waihapa production station via pipeline. So just a quick wander around today.
So yeah, Rez, this is the export gas compressor you say. Tell us a bit about, yeah.
Okay, so this takes the gas from the plant and compresses it to higher pressure and to export through to Waihapa production station. So electrically driven compressor. So it's got a fairly large separator. So this area is the wellhead area, so effectively this is where the oil and gas comes out of the ground. In our operation has been running power fluid, so effectively we've got hot water travelling down the outside of the well, drawing the oil and gas up through the centre into the well bore and then round to the separators for separation.
So the separators are these units here?
Yep, correct. So basically oil and gas comes into the separator, your gas comes off the top of the separator, and your water and oil come off two sides of the weir. So effectively your oil floats on top of your water, spills over the weir, oil out one side, water out the other, and it's a continuous process for us being power fluid. So those two large pumps you see over there are effectively a long barrel pump with electric driver on the end.
Yep.
They're power fluid pumps, so they're pumping up to 255 bar, which is pretty high pressures, from 10 bar, and they generate the energy to lift the oil and gas. Probably won't take photos in here, mate, we're just a bit... The whole thing. Around about 125 stages every pump, that's quite unusual. Hot oil here, it's something like 280 degrees Celsius. We've got power fluid at 120 degrees Celsius, so there's a lot of movement. So that's what these racks are designed to do. They allow the pipes to move. Effectively down through here is QLB, and there's a pipeline easement right through these properties to QLB, which will take you to. Just fairly simple sort of industry standard stuff there, metering, and one side's a flare, which is sort of plant emergency or overpressure or etc. And the rest is Waihapa. Came as a boiler sort of package. And then we have a hot water heater as well, which everything, because of the core point of our oil is so high, basically everything's got to be heated and heat traced. So you've got water heat tracing and electrical heat tracing around the pipe, and that keeps the oil flowing, okay? So that's the hot water heater, and the rest is compressed air, which is the power used to control valves. Okay, so this is where all the power distribution takes place. We generate our own power as well, which I'll show you shortly. But effectively, the big pumps that shows the outside and the compressor are all electrically driven. So of course you've got to distribute the power through these VSD drives here, quite large drives, 250 kilowatts, 300 kilowatts type stuff. And then we also export to the grid, so we tie them to the grid.
Okay, yep.
So basically this is the other end of the pipelines coming into GLA. So this is what we call the pig receivers. And notice here the angle of these receivers is just something that was done and designed to make for safety and make life a bit easier for operations. So basically as the oil comes in with a pig behind it, it's drained, but it's basically self-draining down rather than draining to surface. And being so hot, everything's so hot, we obviously don't want operations, people handling hot oil, so quite successful. And this line here is export gas through to Waihapa. Again, all effectively just a flare pit, a ground flare, and just a big barbecue type burner really in the bottom, if you can imagine that. And yeah, small amount of gas. Basically that's flare purge. What we're seeing there is a safety purge to stop air coming back into the pipe's laid out this way is for expansion and contraction. So of course, take a cold pipe, heat it up to 100 degrees Celsius or more, it's going to move. So again, all the temporary pipe work's gone through design and engineering and certification. So it's permanent. It's just for testing purposes at the moment. And then this well will get permanently tied in, which is what our engineering crew are doing over there at the moment. They're looking at the capex to cost to equipment time for us.
And that's A7 there?
That's A7, yeah. That's our latest well. That's been flowing now about 2 months. So effectively you've got hot power fluid already heated coming up here, 115 degrees Celsius or temperature, up into the headers here, down through the wells, distributed through the 3 producing wells, well stream fluid back, multi-phase pipeline back to the plant, about 2.5 kilometres away. Instrument air is also brought up from the plant, so we've got